What's up everybody, and welcome to part 3 of my Basics of Deep Learning series. In the previous video we have seen that the deep learning algorithm is loosely inspired by how the brain works, and we have also seen that the basic fundamental unit of the brain is the neuron, and this is also what we modeled mathematically. And the way that this artificial neuron works is that we multiply these input values with the respective weights, and then we sum up those products. In this weighted sum we then put into our activation function, which in this case is a step function with the threshold level of 2. So if the weighted sum is equal or bigger than 2, then the output of the neuron will be a 1, and if the weighted sum is smaller than 2, then the output will be a 0. And now if you put together many of such neurons, you get an artificial neural net. And the way that this works is that you feed in your input data here at the front, and then each node in this first hidden layer is going to process these input values in the same way that we saw with this single neuron. And then the outputs of these nodes, they are then going to serve as the inputs for the nodes in the next layer. This way we can keep going through the layers until we reach the last layer to get the output of the neural net. And this process was called feedforward because we are, so to say, feeding forward our input data through the layers to get the decision. And how to implement that feedforward algorithm in code is now the topic of this video. And therefore, we are again using the iceFlower dataset as our use case, and the specific neural net that we want to apply to this dataset looks like this. So we have 4 input values, so the CPU length and width and petal length and width, and then one hidden layer with 2 nodes, and then the last layer is going to consist of 3 nodes. So we are going to one-hot encode our label, which is the species of the flower. So instead of having one column that contains all the different classes, we're going to have 3 columns, one for each class. So for example, if the flower is an Aristosa, then there will be a 1 in this first column, and the other 2 columns will contain a 0. If it is a versicolor, then the 1 will be in the middle column, and if it is a virginica, then there will be a 1 in this last column. And then accordingly, if we input a new unknown flower into our net, then only one of those nodes should output a 1, while the others are 0, depending on what species our neural net predicts this new unknown flower to be. So for this neural net we now want to implement the feedforward algorithm, and since the fundamental unit of such a net is just one neuron, let's start with implementing the functionality of that. And therefore I have already loaded in the iceFlower dataset and also one-hot encoded it, and then also I created a list that contains the input values for one specific flower of this dataset, and it's this one. And then I also created a list that contains the weights that go to this node. And now what we want to do is we want to multiply this input value with this weight, this with that, this with that, and this with that. And then we want to sum up those products. So basically we just want to calculate a weighted sum. And so let's just create a function that does that. And we're going to call it weighted sum. And the parameters of this function are going to be these inputs and the weights. So we're going to say inputs, weights, and then we're going to say total equals 0. And now what we want to do is we want to loop over those 2 lists, and then we want to multiply the first element of this list with the first element of that list. And then we add that product to our total variable. And then we want to do that for all the respective elements. So we're going to say for input value, comma weight in zip inputs weights, and then we're going to say total plus equal input value times the weight and then we are of course returning the total. So that's our function. So now let's see if that works. So we're going to say node input equals weighted sum of our inputs and of our weights. And then we're also going to print this node input. So let's run this, and here we get a weighted sum of 5.21, and this sum we now want to put into our step function. So let's create another function for that. So we're going to call it step function, and here the parameter is just going to be a number, and if that number is bigger or equal to our threshold value, which in this case is 2, then we're going to return a 1. Otherwise, we're going to return a 0. And that's already our function. So now let's see if that works. So we're going to say node output equals step function of our node input. Then we're also going to print that. And now if I run this, we should get a 1 because this weighted sum is bigger than 2. So let's see if that's the case. And we do. So this is now how you could implement the functionality of just one neuron. And obviously our neural net consists of many such neurons. So how do we now determine the output for the whole neural net? One thing we could do is to simply use those two functions to determine the outputs of those two nodes in the hidden layer. And then we store those outputs in the two variables, and those variables we then use to determine the outputs of these nodes. But this seems a little bit tedious, and also for larger neural nets with thousands or even millions of nodes, this is not really a practical approach. So what can we do instead? Well, we can take advantage of the fact that the neural net is organized in layers. So instead of just determining the outputs of these nodes individually, what we can do is simply determine the outputs for this whole layer. And this is now the function that we want to create. So let's call it determine layer outputs. And if you look at this diagram, the parameters of this function are also pretty clear. Namely, to determine the outputs of this hidden layer, we have to use those input values. So again, the inputs, and then these weights. And then obviously the function should return the layer outputs. And then since the neural net is made up of sequential layers, we can then simply use this function again to determine the outputs of this last layer. But here then obviously we use the hidden layer outputs for this inputs parameter, and obviously we also use those weights for the weights parameter. So this is now how the function should generally work. And now let's have a closer look at the underlying structure of those parameters. And then we're also going to think about what this layer outputs variable is going to look like. And therefore we are going to turn this neural net by 90 degrees so that it is upright. And this way I think it will just be easier to keep in mind what the underlying structure of those layers will be. And then also, since this function only determines the outputs of one layer, let's just look at this part of the neural net for now. So the input layer and the hidden layer. And now we're going to start what this weights parameter actually looks like. And therefore, obviously, we now have to consider several nodes and not just one like we did here. So accordingly, the weights parameter is not just going to be a list, but it's going to be a list of lists. And each sublist in this overall list is going to contain the weights that go to a particular node. So for example, this first list is going to contain the weights that go to this first node. So this value is that weight, this value is this weight, this value is that weight, and this last value is this weight. Then the second sublist is going to contain the weights that go to the second node. So this is what the weights parameter is going to look like. And now we're going to look at what the inputs parameter is going to look like. And here too, this is also going to be a list of lists. And that's because in machine learning we are always dealing with many examples and not just one like we did here. So in this case here we have 3 examples, and each sublist is going to contain the features of one specific flower. And since we have 4 input values, each sublist is then going to contain 4 elements. And now, since both of those parameters are lists of lists, let's rename them so that it is clear. So we're going to say list of inputs and then also list of weights. So that's what the parameters are going to look like. And now let's think about what the layer outputs variable is going to look like. And obviously this is also going to be a list of lists, but this time each sublist is only going to contain 2 elements. And that's because we have 2 nodes. So this first number represents the output of this node, and the second number represents the output of that node. And since we want to determine these hidden layer outputs for each of our example, this overall list is also going to contain 3 sublists. This first sublist contains the output or the hidden layer outputs for the first example, the second for the second, and the third for the third example. And hopefully you now understand why I depicted the neural net in this upright representation. Because now you can simply look at the neural net and basically see what the underlying structure of those layers will be. Namely, here we have 4 input values, so the list of lists is going to, so to say, have 4 columns. And here we have 2 nodes, so the list of lists is going to have 2 columns. And then you just have to keep in mind how many examples we are working with, and which is in this case 3. And then no matter how many layers you're going to have in the neural net, each layer will consist of a list of lists with 3 rows. And only the number of columns is going to change based on how many nodes there are. So for example, this output layer, this is going to be a list of lists with 3 rows and 3 columns. So that's how you can easily remember the underlying structure of those layers. And unfortunately, this upright representation doesn't clearly show what the underlying structure of the weights parameter will be. But in a later video, we will also see how that underlying structure is also very easy to keep in mind. So now that we know what the parameters look like and also what the output of this function is going to look like, let's now think about how this function actually works. In other words, how we can determine this list of lists by using these 2 lists of lists. And this will be the topic of the upcoming video. So thanks for watching, and hopefully I will see you in the next video.